Good morning, pre-algebra, and welcome to lesson 4.1, like terms and unlike terms, beginning on page 93 of your textbook. And going through page, 96, so 91 to 96. To begin this unit, which is called algebraic manipulation, you have to understand a few vocabulary words, and this pre-note taking session is quite intense. So remember, you can pause while you're writing things down, rewind, and so forth. So the first thing that we're going to learn in the vocabulary section goes with this expression, 2x minus 3y plus 8. In this expression, you have coefficients, and for example, in this term, you have the coefficient of x is 2. So within the term, the digit 2 is called the coefficient. It's coefficient because it has both the term and the variable. So you have the digit and the variable together. It's a term. The 2 part of it is called the coefficient. In this case, the coefficient of y is -3. And in this case, where there is no variable at all, the numeral itself is simply called a constant term. So constant means no variable. The title of our lessons say like terms and unlike terms, so we need to identify those also. First of all, like terms are terms that have identical variable parts, such as some variable or variables having the same exponents. Also, all constant terms are like terms. So it would be a variable like 2x. This, of course, would have the exponent of 1 is what they're calling this. And of course, they have to be exactly the same in order to be a like term. And then again, all the constants are like terms. Unlike terms then would be the reverse, all terms that are not like terms. Let's put this into some practical examples where you can actually see what they are talking about. So in the example of number 1, 3a and 7a are like terms because both numerals have the variable a. However, 4a and 8b are unlike terms because these numerals have different variables, one being a and one being b. In number 2, 9x squared and -5x squared are like terms. The numerals are different, but the variable to the second power are both identical, so those would be like terms. However, 2y and then 2y squared are unlike terms because y and y squared are different. In the third example, we'll have a negative p2q and a -5 p2q. So remember, with a negative sign, if there's no numeral like a 5 in front of it, imagine a 1. So the like terms in this case is the pq2 in both cases. Unlike terms, however, a -pq squared and a -6p squared q are two different variables, because here the q is squared and here the p is squared. So they're different, so they're unlike. Like terms, remember all constants are like terms even though the numerals are different. If there's no variable, they are like terms. However, if that numeral should have a variable, it is not. It is an unlike term with a numeral that has no variable at all. So there's some examples of like terms and unlike terms. There's just a little bit more note-taking to go, because the crux of this lesson is collecting like terms, because we're going to be simplifying. So the process of simplifying an algebraic expression by adding or subtracting like terms is called collecting the terms, collecting like terms. Note, we cannot simplify an algebraic expression with unlike terms. So you can just simplify or gather them together and condense them if they are like. If they are unlike, that's as far as you can go. So proceeding, try it 1, bottom of page 95. We're going to simplify some expressions. The first one in letter A is 5t plus 6t minus 17. Notice they are all like terms because they all end in t. So simply in this case, we use the order of operations. Adding and subtracting are on par with one another, so we do what comes first. So 5t plus 6t is 11t minus 7t. And when you do that, we end up with 4t because 11 minus 7 is 4, and the variable stays the same. Not the constant, the variable stays the same. So our answer here is 4t, and that's as far as we can go because we don't know what t is worth. Example letter B, negative 4bz minus 3bz plus 5 halves bz. Now the interesting thing here, of course, we have like terms in all cases. Each term has bz in it. The interesting thing here is in algebra with fractions, it's improper, 5 halves. We write 5 halves x, or we would put it in decimal form, 2.5x, but we would not do 2.5x. So when you have a variable with any type of fraction, it's either in fraction form, whether it's regular or improper, proper or improper, or we would convert the improper into a decimal but never a mixed number. So that's just something to keep in mind. Again, because it's subtracting and adding, we work from left to right because these are they're on equal par with each other. So negative 4bz and negative 3bz, we end up adding the opposite, combining the negatives. So we have a negative 7bz plus 5 halves bz. Negative 7bz, I switched it to a decimal because it's easier to add, and it's 2.5bz when I do that. So the negative numeral is higher, so it has a higher absolute value, so my answer is negative. And remember, if you have a negative and a positive, you subtract. So we have a negative 4.5bz, and as I suspected, they turned this into an improper fraction, which is a negative 9 halves bz. Okay, so going on, letter C, again we have like terms, 3n minus 8n plus 5n. So 3n minus 8n is a negative 5n plus a 5n. So negative and a positive, they kind of cancel each other out, as do the variables. So our answer here is simply 0. That takes us through try it 1. In all these examples, we had like terms. All of the terms were like. Now let's go on to the next page, example 2. Try it 2. And letter A is 5c minus 4d minus 3c minus d. Now, we have a mixture of like and unlike terms. So we're going to arrange the like terms together. This is an important step. Do not skip this step. Take this and rearrange it. We're going to get the c's together and the d's together. So I have a positive 5c and a negative 3c, a negative 4d and a negative d. I just line them up like that. And then I combine my like terms. I can combine 5c and negative 3c, which is 2c, and I can combine negative 4d and negative d, which is the same as negative 1d, so I have a negative 5d. At this point, I cannot continue simplifying. It can't be further simplified because we don't have like terms anymore. Therefore, my answer in this case is 2c minus 5d. Going on to example B, 2ax minus 7x plus 3 halves plus ax minus 2x minus 1/5. Now I have two variables of ax. I have two terms with variable x, and then I have two fractions. So I have three separate things here. So I'm going to combine my ax's first. So I have positive 2ax and a positive ax, and then I have a negative 7x and a negative 2x, and then I have 3/2, a positive 3/2, and a negative 1/5. At this point, I just put parentheses around so I keep straight what I need to do. So again, 2ax plus ax, same as 1ax, is 3ax. I'm combining my two negatives. So a negative 7x and a negative 2x is a negative 9x. And then I have a positive 3/2 minus 1/5. Remember, when I have denominators, I have to have the same denominators, so I have to have common denominators. So I, first of all, switch my fractions to 15/10 minus 2/10. I can actually do that. It's 13/10. Looking at this fraction is in simplest form, so I just leave it alone, 13/10. Again, this cannot be further simplified, therefore 3ax minus 9x plus 13/10, which I found working my fractions, is my simplification of that problem. And there we have it. That is our lesson for today. So please look at page 96 at the bottom. Our assignment is number 1, 2, 3, then going on to 97, number 4. So 1, 2, 3, and 4. So you're going to have practice combining like terms, and some will go all the way to is further than others depending on how many like or unlike terms or combinations of the such as we have practiced in example 2 you will run into. So there you have it. Please stop, watch, rewind, pause, get all your notes down, follow your steps. You don't have to add the explanations, but follow your steps. Thank you, and do good math.